Today is all about goals of system engineering, goals of user interface design. Course learning outcome. After this topic, we should be able to explain the basic of human and computational ability and limitation. So at the end of this lesson, the students will be able to know the goals of system engineering and user interface design, value the importance of system engineering and user interface design, as well as explain the basic of human computational ability and limitation. So can you read the first bullet about the definition of system engineering? Let me go on the list. Castile,
Yes, sir.
first bullet, please.
The engineering of system, or popularly known as system engineering in the Philippines, is an interdisciplinary approach which develops technical information to support the decision-making process of management. It takes into account both the organization and the technological needs of all clients with the aim of delivering a reliable product that meets the needs of the consumers.
Okay, thank you. So when we say system engineering, it's actually the process of creating a system that involves different fields. So we have computer science, we have IT, and we have information system. So a system cannot be a whole system if it's not composing of um, a hardware, a software, and a database. So for the database, that's for the information system, Bachelor's of Science in Information System. For the programming or software, the most focused one there is the computer science course. And then for the hardware is the computer engineering course. So the purpose of creating a system is to develop a system to support the decision-making process of a management. And we call that data-driven management. So the one that will analyze the data there would be the data scientist. So as per the definition, the organization and the technological needs of the clients is an important matter. Why? Because the system would be based on the perception of the clients themselves. That's why when you are doing a project, it's very important that you do a survey with your clients before starting a project. So in the designing phase, we will be discussing the different methodologies that needs to be followed in creating a system. So can you read the second bullet, Haronas?
Uh, Sir Hanoras po.
Haronas or Hanoras?
Hanoras.
Hanoras, go.
The engineering of systems, or popularly known as systems engineering in the Philippines, is an interdisciplinary approach which develops technical information to support the decision-making process of management. It takes into account both the organization and the technological needs of all clients, with the aim of delivering a reliable product that meets the needs of the consumers.
I'm actually asking for you to read the second bullet.
Oh,
Not
sorry sir. Akala ko po kasi yun yung first. Ay, second one. Okay. It is also described as an interdisciplinary group process and a method aimed at designing successful systems. It begins by specifying the needs and features of customers before the development of holistic design will proceed. It takes into account both the organization and technological needs of all clients, with the overall aim of delivering a quality product that meets the needs of the consumer.
okay, so in this bullet, it means that system engineering has a goal. So the goal of system engineering is to design a successful system. So we cannot just design a successful system by just doing it. So we have to first specify the needs and features of the customers because the system will be based from them. So we need to do a research. That's why you have a research subject. It's for you to be trained about that because in the industry, that's the first thing that we need to do. We need to do a research before designing a system. And we have to have a specific goal in doing so. So before the development begins, we need to make sure that we take into consideration both the organizational and the technical needs of all of the clients. So we have to interview not only the clients but also the ones assisting them. So with the overall aim of delivering a quality product that meets the needs of the consumer itself. Do you have any questions so far on the first and second bullet class? Class, do you have any question? Okay, I'm monitoring currently right now. John? Somebody else.
High level this
Doesn't need to have a microphone, right? Their hands.
manufacturing.
Read the next bullet, please.
Okay. System engineering ties the economic benefits of modern manufacturing systems with their high-level design to the specification of the subsystem over the entire life cycle of the system, from the initial conception to the retirement of the system.
Okay, so in system engineering, we have this called life cycle of the system. So the life cycle, it means that we are observing from the creation phase up to the testing phase and up to the evaluation phase and until the system retires. So that's the life cycle of the system. When we say the system retires, it's the end of life of the system. Like the components are not working anymore, even if we replace them with a new ones. Okay, so next bullet, um, Erica.
Yes, sir. The process of systems engineering offers a deeper understanding of customer needs and allows program managers to efficiently handle change and configuration across the lifecycle of a project.
Okay, so in a certain system, we also need to consider the change management of the system. So which means that when we say change management, if you are on the testing phase, and then if there are values there that are failing, you have to replace that certain components if it's failing. So we have to test all of the components when you are doing a system. And then for those components that are tested incompatible based on the test result that you performed, you have to replace them with a new one. Why? Because we can only tell that a system is successful if all of the sensors, all of the devices are tested, and if they all pass the testing phase. Any questions so far, class? Any issues? Please type it on thing, and I'll move on now. Okay, so Devera, kindly read the next bullet, please. Devera, can you read the next bullet, please?
Sir, wait, may problema yung slide ko.
Okay, so I'm gonna call another one then. Um, Benavides.
Sir,
Benavides.
the, the V Project Lifecycle Model, industry-based approach to system engineering, and the diagram details the conceptual connection between the various activities or processes in system engineering.
Okay, so this one here, this is just an example of one life cycle project. So this model is called V Project Lifecycle. Why? Because the pattern is like a letter V, as you can see. So this is mostly an industry-based approach being used in automotive technology or in railways technology. So it's actually differ. Your project model will be different depending on your research. So depending on your research, you will choose the appropriate methodology depending on the theories that is involved on your project. So on this one, um, since it's industry, so the research that they made here, um, they found out that it needs an industry approach. Why? Because it's for a railway. That's why they use the B project. So this example, as you can see, it shows the life cycle of the project from the research, which is understanding the problem, up to the assessment of the system or testing and evaluation of the system. So on the research part, they research the needs, the requirements, the design, and the specification of the system. And they also need to understand the solution on the problem. So this is on the research side. On the testing side, they have to validate the decommission or the operational decommission of the system. When we say operational decommission, does the system work based on the objective on your research? Then they verify if the requirements are met. They verified as well if the integration support the design that was originally designed in written form. And then, are they going to accept the specifications that was researched based on the testing phase that has been done? So based on this one, they have to assess the cost and the risk if they are going to approve or disapprove this project. So if all of these are met, technically this will be approved. But if one of this will fail, one of the testing and implementation will fail, they will disapprove the project and they will request for a new one. Okay, next bullet, please. Galvez, next bullet, please.
I can see it. Sir, I can see the next bullet.
You can zoom it. Are you using a phone?
Yes, sir.
Okay. Torres, Prince Torres.
Sir.
Prince Torres.
Yes, sir.
Please read the next bullet.
In a team effort, systems engineering incorporates other disciplines and specialization classes, creating an organized process that goes from development, production, verification, deployment, operations, support, disposal, and user training.
Okay, so in this bullet, it's just explaining that in systems engineering you cannot volunteer yourself if it's not your field because it requires a specialization per process. So let's say for example, for the research, we have this what we call the research specialist. For the creation of the hardware, we have this computer engineering. For the programming, we have the computer science. For the creation of the database, we have the information system. For the testing, we have this testers that we call. And then we also have the implementers. So in system engineering, if it's not your part, you cannot do the job. So it needs to be assigned to you because based on the study, it should be assigned to the one that specializes with that to avoid error. So do we understand that, class?
Yes po, sir.
How about the others? Do we understand that
Yes, sir.
what we are teaching
Yes,
is
sir.
Yes, sir.
engineering?
Yes, sir.
Yes.
Sir.
Gaspar.
Yes, sir.
Gaspar? Joy Tablan.
There are a lot of and consumers System engineering is takes into account the needs and wants of all the consumers to make a good quality system, and also they they needs they needs researches to before making a system. And when it comes to doing the system, there are a lot of specialization in making.
Okay, Chodoro. Chodoro. Kenji Cedric Chodoro.
In system engineering, they are the ones who make the program. They do researches before making program, and when every system engineering has their roles in their jobs and specializations.
Can you give one example of a rule and what should be the specialization?
Um, UI making,
Sorry.
UI making.
Okay, and what specialization should handle those things? What specialization should handle those things?
The UI programmer or designer.
UI designer, correct. Thank you so much. How about Galang? Joshua Ira Galang. Joshua I
Um,
Josel Ronquillo.
Yes, sir. Sir.
Yes, what have you understood so far?
Sir, before making an program, it needs a lot of research, and you need to be a professional or in that field. Yeah.
Anything else that you've understood so far?
That's all, sir. That's all I can share, sir.
So from the beginning that I've discussed up until now, which part?
Oh, confused if. Okay, sir.
Because so since the
engineers. System sir.
what
Sir.
have you
Sorry,
understood
sir.
so
What's the
far?
question, sir? System sir consists of a hardware, software, and a database, sir, which are managed by different fields. For example, the hardware are managed by computer engineers. The software are managed by computer science experts, and the database are managed by information system experts, sir.
Okay,
Hey,
thank you.
yo.
Catherine Martinez. Catherine Martinez. Okay. Microphone is not working though, as per her. Angela Jane Oxtero. Angela Jane Oxtero.
Sir,
Yes. Can you explain the first bullet, please? What we've discussed on the first bullet.
uh, research is the most important for them, sir, so that they can start the program. How will they make it?
Any other explanation about the first bullet that we've discussed earlier? Are you still
problem, or
so? What have you understood so far?
I have understood so far, sir, that we must first understand the problem, or what program we will make to through the perceptions of the client. Then we must assess the system. If the implementation and risk just fail, or uh, if it fail, we must get another research to become its success. Uh,
Okay, thank you for that answer. That's enough. It seems like you're really listening with the discussion. How about Baldelovar? Earl Jude Baldelovar. Earl Jude Bardelovar. Earl Jude.
And the in system engineering, there are many specializations and roles.
Okay. So since we have a few seconds left before it's gonna be an hour, since it's Chad mandated memo for 1 hour synchronous only. So so you will
Where we will pass it po, sir.